Let's look at another example. This time we're looking at x squared minus 1 over x minus 1, and again the limit as x goes to 1. So our function, remember we're finding the limit of a function here, not a gradient. So f of x equals x squared minus 1 over x minus 1. And we want to know what happens to this function as x approaches 1 from above. So x approaches 1 from above and x approaches 1 from below. And that's how we can define above and below. Now, if I look at the graph, so you can visually see what's happening, you can see that there is a hole there. Okay? So that hole means that x can't equal 1. Why is that? Well, if we look at the function, we have x minus 1 in our denominator. Now, we know we can't divide by 0. That means that x minus 1 can't equal 0, which means x can't equal 1 if you add that 1 to both sides. And that's why we have that hole. So as the function is undefined as x equals 1, we can't just substitute into the formula like we did previously for substitution. Okay, and that's because if we do, we'll get an undefined value or answer. We can't do it. 1 minus 1 is 0. We can't divide by 0. So this is kind of like I like to see it as the true meaning of limits. It's normally because something isn't defined at a particular point, so we want to know what the value approaches at that point. It won't equal it, but it's approaching it. So here you have the limit as x goes to 1 of x squared minus 1 over x minus 1. What we can do is if you look at the numerator, x squared minus 1, we can factorize that. Difference of perfect squares, x plus 1, x minus 1. X minus 1 in the numerator, x minus 1 in the denominator. So they can cancel out, and we're left with a limit as x goes to 1 of x plus 1. Now we can substitute. So 1 plus 1 is 2. So our limit as x goes to 1 of x squared minus 1 over x minus 1 is 2. Graphical method, very easy to see. If you are in a tech active exam, I recommend that graphical method. So as x approaches 1 from below, you can see these red arrows getting closer and closer to 1 from below, and you can see our y value is approaching 2. X approaches 1 from above. You can see with the green lines, as x gets smaller and smaller, 3, 2, 1, our y value is approaching 2. Spreadsheet calculations look exactly the same as that previous example. Exactly the same values because we essentially have the same line. It just has that hole, that undefined part at x is 1. So our limit as x goes to 1 of x squared minus 1 over x minus 1 equals 2. Now, I didn't explain this in the previous video, so I will just say it now. You can go x approaches 1 from below of x squared minus 1 over x minus 1 equals 2. Limit as x approaches 1 from above, x squared minus 1 over x minus 1 equals 2. Okay, again, as both are equal, the limit exists, okay, and is 2.